Hi, in this next episode, we're going to talk about Umask. Think about on a server where you might have to meet some compliance. What I mean by that is you have to ensure that new files and new directories have a certain set of permissions. Well, how can you do that without those files actually being created? It's by using the Umask. The Umask allows you to define the default permissions for new files and directories. You can set a Umask value or see what it is to let you know what the default permissions will be for new files and directories and change it according to the Umask. How it works is you are simply defining which permissions are not allowed on different on new files and directories by masking them off. So here, for the users, you are not masking anything. For the group, you are masking the 2-bit, which is the write bit. And the same thing for others. So when it comes to new files and directories, the default behavior is that if you are not the user owner and you are part of the group or part of others, well, hey, you will not get to use the write bit. So you can see how the Umask value can be used in order to really dictate access level on files and directories when it comes to user, group, and others. In the upcoming lab, we're going to show how to identify the Umask value, what it exactly means when it comes to the number of bits you can or cannot use, and how to set the Umask value to set default permissions on files and directories on Linux. Please stay tuned for this lab. In this episode, we're going to explore how to use the Umask value in order to set default permissions. Now, the Umask value is a number that will be able to help you identify the default permissions on a server for files and directories. Let me show you how. Let's open a notepad and go ahead and talk about files. So generally speaking, typically most files are not executables because most of the files we write aren't actually scripts or programs. So the maximum permission they should have is read and write. The execute is only in certain cases. So usually for files, the maximum permission is usually 6. For user, 6 and 6, right? Based on this logic. Now, this is the maximum permission set. Now, subtracting a Umask from that can give you the results of a default value. The default permissions that your files will take on when you create files. So Umask is, again, a number that you set that will define the default permissions. What it's really meant to do is in the name itself. It is meant to mask off or close off certain permissions, whether it's the 4 permission, the 2 permission, or the 1 permission, based on read, write, and execute, and you can mask off certain permissions. So at the user level, you generally will not mask off certain permissions, so you'd give 0 for your Umask, which is normal. But for group and others, you may want to mask off certain permissions. You might want to mask off the read and write permission. Again, execute will ignore when it comes to files, but of course you should understand that when it comes to directories, that execute bit is automatically implied or should be implied and considered based on the calculations. So let's say at the group level, we also want to mask off all of them, the read bit as well as the write bit. So you will mask this off. And for others, you will also say you want to mask off 4 as well as 2. So this would then be your Umask. Now, when you subtract the maximum permissions by your Umask, you should get 6 here, and then a 0, and then a 0. This is the resultant permission set that you are going to get when applying a specific Umask. So this is that relationship that should be understood. The maximum permission subtracted by the Umask will give you the default permission set. So when you log into your terminal here, you can actually type umask to identify what is the umask value that is being used. And again, we see 0022. Now, this simply means that that first 0 is for special permissions. We generally don't touch it. And we have 0022. So what this means is that when I create files, generally this would be the default permission set by this subtraction. 666 minus 022 is 644. Now let's see if this is the case. Let's go ahead and create a directory, new, and go into this directory with cd, meaning change directory, and create a file in here called new file. Now watch what happens. That new file is taking on this 644 permission set. That is exactly what we calculated based on the umask. Because of the umask it being 0022. Now let's say we want to apply a new default set. We want to apply 600. Well, based on this calculation, this should be then 60066 to get a resultant default permission of 0600. So let's apply this umask. Let's type umask 0066. And now with this new umask applied, let's create a new file. Touch new file 02. And you can see the new umask is now being applied and giving me a resultant permission set of 6, 0, and 0. So this is how you can use the umask value in order to apply a new permission set for files that really haven't fully been created or that I plan to create in this session. I hope you've learned something about using umask to apply default permissions on Linux. Thank you for watching this episode, and I'll see you in the next one.